Welcome to the mind-bending world of quantum computing, where your once traditional digital bits can now exist in multiple states at once, and seemingly impossible computations can now be performed at seriously unimaginable speeds. If you're still dwelling in the comparatively slow, sticky, soon-to-be antiquated time of classical computing, which most of us are just at the moment, then listen up, because here's how the world is soon going to change. In today's video, we're taking a journey through the ever-growing quantum landscape, but with future technology particularly in mind. We'll unravel the early mysteries of quantum computing, exploring its basics, the breakthroughs so far, the incredible future predictions, and also the ethical considerations that come with such revolutionary ideas. So let's get to it. First off, the basics. The first thing you need to know is that quantum computing is built around qubits. These are the quantum versions of traditional bits of information as used in classical computing systems. Imagine a classical computer as a reliable office worker. They're always on time, they rarely let you down, they've probably earned their fair share of Employee of the Month awards. What that office worker does is process information through a series of yes or no questions represented as bits, or zeros and ones. And to cut a long comparison short, this does allow them to get quite a lot done reasonably efficiently. It's just that there are limits. Limits in terms of time, speed, and there are some calculations that our office worker, the classical computer, just can't do. With the advent of quantum computing, though, all those limits are being well and truly bypassed. Quantum computing introduces a new player to the game, the quantum bit, or qubit. And the key difference is that unlike with classical bits, qubits can exist in a state of 0, 1, or both simultaneously, thanks to the underlying principles of quantum superposition. Immediately then, there are significantly, perhaps infinitely more possibilities with the qubit, meaning more information held and processed. To return to our office worker comparison, the qubit is what it would be like if our classical worker were to suddenly learn how to duplicate themselves. Now that worker could do way more than just their own usual tasks. They could perhaps run whole departments, whole floors, maybe even entire buildings and businesses single-handedly, because there's the potential for variations of them, which ultimately is why people have been getting quite excited about quantum computing. If it works well, it'll dramatically save time, cut costs, and improve output all at once. Here, the phrase quantum leap actually isn't overstating it. It really could be a colossal game changer. So how did we get to this point? Because it's not as though the qubit just arrived unannounced. Quantum computing may sound like a concept from the distant future, but its roots go back to the early 1980s when physicists, including Richard Feynman, first proposed the idea of simulating quantum systems, as seen in general physics, but in a technological way, through quantum computers. Significant milestones in the time since include Peter Shor's algorithm in 1994, which demonstrated the potential for quantum computers to factor large numbers exponentially faster than classical computers ever could. And then, in the early 21st century, researchers like Google, IBM, and Rigetti began developing better and better processors under this new and growing strategy. Google's quantum supremacy announcement in 2019 marked another pivotal moment, with quantum supremacy alluding to the moment when a quantum computer achieves something that a classical computer never could. It was claimed that Google's quantum processor, Sycamore, could perform a particular calculation in 200 seconds. The really impressive thing being that it would have reportedly taken the most powerful of traditional supercomputers more than 10,000 years to complete the same task. If the watching world hadn't yet believed in the power of quantum computing before then, they did afterwards. It hasn't been all plain sailing, but we have already seen some major fixes as well. Since 2020 especially, there's been an industry-wide focus on correcting errors in quantum computations and on solving specific optimization problems, all with the end goal of building the most efficient final products possible. But, and perhaps most interestingly of all, in 2021, the Chinese satellite Mycius, officially named Quantum Experiments at Space Scale, was used to demonstrate actual teleportation at the quantum level. More than just a science fiction superpower, though, this could soon ensure smoother than smooth instant quantum communication. It may take a few years for the real-world applications to reveal themselves, but when they do, it could, again, prove a major turning point. Such breakthroughs and more serve to showcase the transformative potential of this technology in general and at a mind-blowing pace. In just a few short years, we've seen quantum computing not only emerge in the mainstream, but systematically correct itself, connect itself, and perfect itself for optimum output. And in all of those cases, the performance is only set to get better and better. These are computers, then, with an effectively bottomless pit of processing and energy potential. Glitches, freezes, and crashes could all soon be forgotten annoyances of the past, while our already reasonably fast speeds should dramatically improve as well. In the next decade or so, it's expected that we'll see the creation of increasingly more robust and error-tolerant quantum processors. And the key development here is that, when it's reliable and eventually affordable, quantum computing should also be made accessible to a broader audience. Sectors like finance, healthcare, and logistics are all likely to benefit from optimized quantum algorithms, solving complex problems that were once deemed impractical or even impossible for classical computers. In finance, this means literally instant banking and could also prove the final nail for physical cash. Meanwhile, it might have some further unforeseen consequences in the real-time running of the stock market. In health, quantum computing should mean safer than ever critical care. But the greatest effects may yet come in research, with developers and physicians perhaps able to experiment faster and further than ever before, testing the effectiveness of drugs, cures, and novel treatments within days, hours, even within moments. In logistics, quantum computing might one day enable truly reliable public transport down to milliseconds, as well as always and unbreakably on smart cities, the like of which we've seen begin to take shape in the 21st century. Climate modeling, personalized medicine, energy optimization, universe mapping, all could benefit from this new means of information power. We're likely to see a quantum butterfly effect ripple across basically all fields, although perhaps none more so than with AI. The integration of quantum algorithms with artificial intelligence may birth another new era of machine learning, allowing for unprecedented advancements in natural language processing, image recognition, and decision-making. To today's mind, there may be nothing that a quantum robot can't do. Perhaps unsurprisingly, then, there are some concerns about what's coming as well. For example, with privacy. While it can revolutionize encryption methods, rendering current standards obsolete, there are fears that quantum computing will also pose a threat to data, that it could easily crack all or most existing cryptographic systems, potentially compromising sensitive information. Meanwhile, there's also that now ever-present anxiety of breaching the so-called AI singularity, when machines surpass human capabilities. Quantum computing is sure to fast-track that. And finally, there's the potential for wealth disparities. Access to this technology may create a new digital divide, with only well-funded individuals, corporations, and research institutions having the means to fully harness it. For everyone else, it may for a long time prove little more than a fun trend or gimmick. Striking a balance between widening access and ensuring responsible use will be crucial to prevent worsening existing inequalities. While the future could be pitched as a quantum minefield, however, perhaps it's fairer to view it more positively as the quantum frontier. Right now, we're seemingly on the brink of unparalleled computing power, transformative technologies, and hopefully, life-enhancing innovations. How do you think history will remember this next tech revolution? What do you think we need to do to ensure that quantum products are responsibly developed for the betterment of humanity? And is there one area in particular in which you foresee huge change on the horizon? Because for now, that's how quantum